welcome to MC FLO. Today we will show you how easy it is to make Monte Carlo simulations using MC FLO for Microsoft Excel and Windows. So first of all, let us remind you that MC FLO is a very lightweight but yet powerful Monte Carlo simulation tool to be used with Microsoft Excel and Windows. So this is a basic file, it's called XXL, and so we have also a DLL file, and that's certainly all that you need to perform Monte Carlo simulations. So let us begin with the embedded file, which is shipped with MC FLO. So this is basically an investment model. We have some known parameters which will behave certainly in the future as has been defined here within the model. Then we have some unknown parameters or uncertain parameters where we are not sure which value will prevail in the future, but we have some beliefs how it should be or how it should behave in the future. So we define some uncertain parameters or some random variables, and now we shift to the visual simulation mode of MC FLO. So we see here that we have defined a uniform distribution for the first random variable, which is called volume. So it will take values between 900 and 1600. Then we have also other parameters defined, like this one, which is called outside, which is a random variable which behaves as a normal distribution. So then we have also other parameters like the initial growth rate, which is designed as a triangular distribution. And then we have other functions like here, also a uniform distribution, which uses as initial output the beforehand defined distribution for the initial growth rate. So what we also can do in our model is to define correlations. Here we have defined a correlation between volume and unit costs. So this is typically for investment projects where higher volumes induce or typically induce lower unit costs. So then we have all the logic where we combine certain parameters and uncertain parameters, and then at least we have we have also output variables. So how do we define the input variables, correlations, and the output variables? So first of all, you can use our rhythm fields, which will open the classical editor of Microsoft Excel. We can enter the lower and upper limit here for the defined distribution, triangle distribution, and also the most probable value. Then we have also the option to choose our wizard, where you can choose from different distribution here. We can change the number of bars that we would like to display. We can change here our lower limit, taking 0.1, and then we have a new distribution. We can change the mode, switch it to 0.7, and then we have, with one click, a new distribution. We can change the number of iteration and so on. And yes, we can change we can choose any distribution. So we can use our magic stripe to look at the cumulative probability density or cumulative density function, and to other percentages that we have here calculated for a specific random variable. So we can give it a name, say my1, and then we can save the variable, and then it will be saved within the model. So we can also choose, this cell has been used. Then we can also insert correlations. We can choose any, like the my1 that we have defined previously. We will choose in another variable, and now we can specify the correlation intensity between those variables as positive or negative, and we click OK, and it will be registered automatically within MC FLO. So we can go to the input variables that we have defined, and automatically it will open with a new window the specified random variable. So for this purpose we will delete those variables that we have been defined. You will see it will show an input, it will be deleted automatically. So what we are doing now is to choose or to run a simulation with 1000 iterations that we have defined here. We define a best case, a real case and a worst case, and we have also locked here a variable. You can see here this variable has been locked within with the expected value of 1. We can unlock or we can lock specified variables. Now we start our simulation, not with the input variable. We start a simulation for the entire model. Now we'll see here that the model begins with calculating a simulation without correlation, and then it will choose the correlation parameters, the right correlation parameters, to make a calculation with the correlation that has been defined. Now it will open a new output window. We see here the cost of goods sales. Now we can change to any input variable or output variable. We see the corresponding results of the Monte Carlo simulation. Here for the free cash flows, and here also for the NPV. These are the real numbers of the 1000 iterations that have been calculated. And we see here the main drivers which have enforcement regarding to the NPV. We see here the most important variable are the project costs, and the second also very prominent variable is the volume, which have high impact on the NPV. If you look at another variable, choosing for example free cash flow, you see here that it's remaining nearly the same. Here we see that the volume has a higher impact on free cash flow than on the NPV because of the discount factor which has been taken in the NPV calculation. So we can also look at the input variables, and we see also here the realization of the correlations. Here on the right side we have also defined some functions of MC FLO. You will see here the certainty that the NPV will be higher than 0. It's about 94%. We see here the expected loss, where we have a loss of an NPV which is lower than 0, and we see here the value for the best case, and also here the value for the real case, where we have a chance that 50% of the results might be at the left side of the real case, and 50% that they might be on the right side of 230,000. So we see also here the correlations. Here we have defined correlations rank from Pearson, and we see here also the corresponding variable at the first, second, and here also on the third place. So that's all. Next video we will show you how to analyze the Monte Carlo simulations results within the Excel workbook. And if you have any questions, don't hesitate to contact us. Thank you very much.